This short video will walk you through a simple Java program that uses several if statements to solve a problem. The code was written in Android Studio. A user indicates the current weekly mileage they are running, the distance of an upcoming race they hope to compete in, and the number of weeks until the race is held. Let's take a closer look at the code. We can see these first 3 lines gather the necessary information from the user. We use the race distance indicated by the user to determine the number of miles a runner should be logging before the race date. We use the race distance indicated by the user to determine the number of miles a runner should be logging per week by the race date. There are 3 race distances, and every selection will fall into one of these 3 choices: the half marathon, the 10K, or the 5K race. For simplicity, we have used characters to signify the user's choice. Let's assume the user has entered their choice from a menu: A for half marathon, B for 10K, and C for 5K. Let's also assume that the user input only A, B, or C, and no other character. Keep that idea in mind. The knowledge you will gain when you have completed this entire module will help you to build the code needed to write these sorts of checks and ensure the validity of user input. Assuming the user has a choice from only the 3 menu items, we would need 3 paths through the if block that would call for 2 tests. Here, an if-else-if will work well. If the user chose the half marathon, or A, their goal weekly mileage will be set at 30. If they chose the 10K, or B, their goal weekly mileage will be set at 20. Otherwise, they must have chosen C, the 5K, and we set the mileage at 15 miles. To determine if the runner can achieve that goal mileage in the number of weeks they have left to train, we need to do a bit of math. If you're not interested in deconstructing this calculation right now, just skip through the next 2 slides. A good rule of thumb for runners is to increase their mileage by no more than 10% per week. In week 1, a runner can therefore log 10% more miles than they ran before they began using this app. That's the current mileage times 1.1. In week 2, the runner can add an additional 10% of mileage. Notice that is 10% more than what they ran last week. So we multiply week 1's mileage by 10%, or 1.1. We can simplify that calculation to current mileage times 1.1 squared. Noting a pattern here, we can see that in week K, the runner will be finishing current mileage times 1.1 to the K power. We know the goal mileage already. What we don't know is how many weeks it will take to reach that goal mileage. Therefore, we must solve for K in this equation. Using some pretty straightforward math, we see that our final equation is not a pretty one, but it does give us our answer. We will need to round up or take the ceiling of our final calculation to arrive at a whole number or integer answer. Returning to our code, you can see the 2 lines of calculation we used to solve for the number of needed weeks. With that number, we need to see if the runner has enough time to reach that goal. We must compare the needed weeks to the number of weeks the user has input. We first check to see if the user can meet the goal. Are the needed weeks less than or equal to the weeks available that the runner has input into the app? If there is enough time, we'll print out some instructions on training. If there is not enough time, we need to print a message letting the user know that the choices they have indicated won't work. But they may be able to select a shorter race and try the calculations again. So now we need to see if they've chosen the 5K race, or C. If they have, then there's nothing left to suggest. But if they've chosen the 10K or half marathon race, then we can suggest they look at running a shorter race and thus decrease their goal mileage. Here is the code for the second if block. First, we check to see if they can accomplish the goal in the allotted number of weeks. If they cannot, we begin to print out the appropriate message. Here we used an embedded else statement, as opposed to the if-else if we used in the first code block. This allows us to execute these output statements, then continue with a second conditional. If the user has chosen that shortest race, then we simply end the message here. Else, we continue the output by suggesting a shorter race. In all cases, a good luck message is printed at the end. Here is a look at the entire code with some helpful diagrams of the if blocks. The if-else-if blocks allows us to determine which of the 3 races a user has chosen and assign goal mileage based on that choice. The nested if statements make it possible to execute lines of code in steps, depending on the result of several conditionals. Altogether, we have an easily readable process that produces the correct output every time.